everyone here. Whenever you like. Yeah.
Hello, we are of the School of Escolapios Salasan, and we are Marcos,
Leire, Inés,
and Laika. And we want to explain our project. Have you ever felt the satisfaction of finding the perfect garment with a ridiculous place? This is a problem, but the science is clear. When the place is almost invisible, the environmental demand is impossible to hide.
that was one of the first questions we asked ourselves at the beginning of the project. To answer this question, we start to investigate. The first question we investigate at internet were what are microplastics, where they come from, and where we can find them.
Microplastics are very small plastic particles, usually less than 5 millimeters in size, that can come from a wide variety of sources.
For our experiment, the first thing we needed was to collect samples. Before putting the clothes in the dryer, we had to clean the filter. Then we had to write what had been dried. We dried the clothes in the dryer, and once they were dry, we took out the filter very slowly so that air currents didn't scatter the fibers. Instead of shredding the cloth, we tried it to peel it up like a sheet so it would be easier to investigate later.
Once we had the samples, we started to experiment. The first practice we did was to know how fibers behave in salt water and in water, since microplastics are found in seas and oceans. And we have found that neither cotton or synthetic fibers, neither cotton or synthetic fibers float in the water, but the polyester and nylon float in salt water but not in plain water.
We do experiments with electricity and with acetone. And in the electricity one, we use a balloon and all the microplastics struck except the cotton that's struck with difficulty. And in the acetone one, all the microplastics stay the same.
Slightly. There is no change in the cotton.
The changes were already enabled within the first 5 minutes.
We also dissect muscles to find the 9 microplastic that they supposed to have, but we doesn't find anything.
Finally, we would like to share with you some news that we found shocking. One of the news mentioned that in Navarra, sheep's wool is no longer profitable. It is used to bring in a bit of money. Now, we are just grateful if they take it away. That was the view of a farmer, as wool has become an expensive bargain for farmers due to a lack of a market compared to synthetic fibers. And what can we do? We can buy less and preferably recycled, support responsible brands, and wash less and at lower temperatures.
Thank you for your attention. That was our project. And of course, if you have any questions, we are ready to answer them.
I do have a question. What was the most difficult part in the project?
I think that the muscles, the experiment with the muscles.
Why?
Because we have to wait 24 hours so that to be prepared, so for them to be prepared, and finally it didn't happen how we think it would.
Thank you.
Which is the problem with the microplastic? Why is important to research this topic?
Because I think we don't think in this because we don't see the microplastics and we inhale the microplastics. Mm,
And it can be harmful for us.
Okay. Okay, thank you very much.
Thank you.
We have some certificates here. Yes. Laia. Across. And then, right, and that's also. Okay.
Hello, we are the School of Resources, and I am Laia.
Leslie,
Honey. And we are going to say our project air pollution. We are presenting our project. Our objective is find an efficient and sustainable way to travel. And we were studying a lot of filters to do nail wings to the plane. Aviation and cellulose. Cellulose accounts for only 1/3 of aviation's limits in parts. Non-cellulose effects like athletes cause twice as much warming as cellulose emission alone. Rate of pollution. Flight has evolved from a mechanical velocity into a democratic way to travel by tourists outdoors. Global warming affects everyone. Who is Michelle? Michelle is from the astronaut NASA, and it was studying this, making aviation more effective and sustainable, creating design based on biometry for aerodynamic essence. A role model for the next generation of students in STEM.
They read a text of cultures
and that instead of they can fly. If we reduce drop which aerodynamics design base in future, wings the thrust ratio will be low and fuel consumption will increase. We really believe that high design base and natural will reduce risk and save energy. In the science that studied natural harm as a soft I think inspired of innovative technology, it seeks to slow humans problem that natural has really been through system model mechanics process that exist or are inspired by the natural world. First, we leave the
Model. There, these are the models that we have created here. We are one with a planet based design and the other with a design inspired by vultures' wings. Material that we have used: straws of paper, a bottle, a ruler, a fan, and 2 bottles. We have followed this process. First, we cut the side of this bottle. Then we put this wing of a bottle. Then we stick this together. And after that, we stick these straws of paper. And we make the same, but here is a plate. Scientific theories. We have taken into account 2 important theories. One, the tertiary effect explains what a wind can make an airplane or a vulture goes and attention to air and pressure. Newton's third law says that for every action there is an equal and pushes the air downward. The air pushes the wind upward with the same force. Results. The results of the test carried about with the models demonstrate that more efficient aviation is possible. We figure it out using the following formulation. Here you can see.
We can say 20%. In 2019, the contamination decreasing a lot because the COVID affected the people. I want to talk about 2 problems that we have. The first problem, we had to design 1 bottle, 2 bottles, because one bottle wasn't big enough, the 2 models win. So maybe the results are not exactly concreted. The second problem, we tried to cover the bottom of the bottle with straws, but because the high temperature of the silicone, they melted, and we have to
think another solution. Thank you for listening to us, and remember, the solution to protect the planet is not to travel less, but to travel better. We hope you have enjoyed it.
Don't use the microphone so you can hear you. Yep.
Okay, thank you for your presentation. I want to ask just one question. Do you find it difficult to repeat the same thing, like constructing the bottle several times, or was it something that you find that you are learning with the process?
Can you repeat the question?
Yes, you had to construct two bottles 2 times. Was it frustrating, or was it something that you learned by doing it? No, yes?
Okay. The first bottle we construct with a different, because the wings were the wings of the butcher we constructed it for the airplane, because the wings of the butcher can move with the hot air and thermal.
Okay. Any more questions? Go and get it. Yeah.
So you were measuring the aerodynamics of the wings. Which one was better and why?
It was better the plane because it was easier.
Okay. Cheers. Okay. Thank you very much.
Thank you.
Right. Go ahead.
Good morning, judges, and thank you for coming here today. We are the science team from Beaver School. We are 4 junior scientists. Mario, the lab technical, Dylan, the data analyst, Victor, the experiment supervisor, and myself, Annie, the sample manager. We have worked together on our project about melting ice. Today, we are going to present our project called Cold Facts: What melts ice faster? We have chosen this topic because we are curious about how ice melts and why some substances make it melt faster than others. We also want to know what is the science behind this process and know what is happening in the poles. Our scientific question was, which substance melts ice faster? We went for common substances: salt, sugar, vinegar, and baking soda. Our hypothesis was that the salt will melt the ice faster because the lower the freezing point of water more than sugar, vinegar, or baking soda. The freezing point goes down, the ice melts faster.
In our experiment, we used 3 types of variables. First, the independent variable, that is the substance we use in the ice. Second, the dependent variable, that is the time the ice needs to melt. Third, the controlled variable, that is the same in all trials, like the room temperature, the size of the ice cubes, and more. Materials. In our experiment, we use the trial materials, like identical ice cubes, glasses, salt, sugar, vinegar, baking soda, a digital watch, a measuring spoon, a mobile phone camera, and a data table made in Excel, and paper and pencil to write our observation. This is how we did our experiment. First, we placed 1 ice cube in each glass. Then we labeled the glasses. Next we put 1 teaspoon of each substance in each glasses. Then we start the stopwatch and observe the ice every minute and wrote the changes. Then we stop the stopwatch when the ice are completely melted. Then we repeat the experiment 3 times and finally compare the results on graphs.
In our results, we see clear differences between the substances. Salt melt the ice the fastest in all 3 trials. The ice cube with salt lost its shape quickly and became liquid much sooner than the others. Vinegar and baking soda melt the ice at a medium speed. Sometimes they were similar, but they were slower than salt. Sugar was the slowest substance in all 3 trials. The ice cube with sugar took much time than the others in melting. After collecting the data, we calculate the average and made a bar graph. In the graph, the salt bar was the shortest bar, and the sugar bar was the longest bar. This confirmed our hypothesis. Salt melts the ice the fastest. Why do some substances melt ice faster than others? Ice is made of water molecules that produce a crystal structure that we need to break this structure to melt the ice. Some substances have a lower freezing point and melt the ice faster. This effect is called freezing point depression. Salt is the faster ice melter. When salt touches the ice, it dissolves into ions, and these ions interfere with the ice and melt faster. Sugar has big molecules. Sugar have big molecules and not for ions, so they distort the ice. So they don't distort the ice very much. Vinegar is a little bit acid. Vinyl is a bit of heat and change the pitch, but it's a weak. Vinyl melt a bit, but not a lot. Baking soda. Baking soda is basic. Baking soda, it also takes the water around the ice, and it acts like the vinyl. The conclusion is that our experiment shows that the ice melts faster when the temperature changes. In the post, the temperature is changing and is rising, so the ice melts faster too. Thank you very much for your attention and for listening to our project. If you have any question, sorry.
In our experiment, the ice melts faster because we change its conditions with substances. In the plants, the same idea happens, but for different reasons. The air and the ocean temperature is rising, so the ice cannot stay solid anymore. And it's like in our experiment. When the conditions change, the ice melts.
Thank you for listening to our project. And if you have any question, we will be happy to answer. And if we don't know it, we will investigate it later.
I want to know why were you concerned about the ice of the poles?
Because we are preoccupied about how the ice is melting so fast in the poles, and we will only have water in the world.
Very good. When analyzing the results, did you see any difference within the replicates for each substance? Because you did it 3 times. So were them all the same number?
No, but all the 3 are very similar.
And why is that possible? Why is the difference?
That we put more substance in the ice cube or less substance in the ice.
More.
So did you do the replicates in different days or at the same day?
What?
The replicates of each substance was done in different days or at the same
Yes,
day?
in different days.
Okay, thank you very much. Go ahead.
Hello, good morning. We are the Miravalles of the New School, and today we're going to present the Mediterranean diet.
Hi everyone. Today I am going to interview a group of professionals who one day decide to work on a project to answer the following question. Can everybody follow the Mediterranean diet to stay healthy? Or does it need big changes for different healthy problems? As you probably know, the Mediterranean diet is a healthy way of living based on fresh local foods. It is mainly composed of fruits, vegetables, beans, and nuts. Well-green cereals and smart proteins like fish and eggs, and dairy and less red meat. The main character is a great healthy fat called extra virgin olive oil, and don't forget water as the main drink. Is this correct, Mrs. Nari?
You have mentioned the most important food, but I will add one more essential ingredient. Staying healthy by sharing food with friends and family, keeping active, exercising daily, and choosing local and seasonal food.
Your project pretends to point out the importance of our healthy in our diet, but in which way?
Well, I think I can answer your question. Eating this way is scientifically proven to protect your heart and improve blood flow while keeping your memory sharp and your brain healthy. It also helps maintain stable blood sugar levels and helps you reach a healthy weight for your age. Maybe a mother of a family can have more interesting ideas.
Oh yes, I think that it is important to point out that this diet is perfect for everyone. It helps keep brain growth, gives us the steady energy to do sports, and protect the memory of older people. It is a healthy way of eating to feel good at any age.
So what is your hypothesis?
Well, as we know, the Mediterranean diet can be adapted to meet a specific nutritional needs varies of family members.
Well, I understand that the project pretends to point out the importance of many ages, but in which way?
I think I can answer your question. At the first stage of our project, we were wondering whether a basic diet like this one is easy to adapt to any health condition, such as diabetes, cholesterol, obesity, celiac disease, cardiovascular problems, and even persons with Alzheimer's disease. I am forgetting anything?
Right, we learned that the Mediterranean diet is beneficial for managing several diseases. For instance, a person with diabetes can eat several times a day. Low energy like beans, whole grains, and fiber are ingredients that prevent blood sugar spikes, which keep the pancreas from working too hard. If you have obesity, if you have obesity, the healthy fats if you have omega-3, obesity. By eating healthy fats like olive oil and fish rather than processed fats, it's easier for the body to maintain a healthy weight. If you have high cholesterol, the omega-3 in oily fish helps clear the bad cholesterol from your blood, keeping your heart clean and strong. People with Alzheimer's, the healthy fats are a shield for the brain, helping to protect memory and keep the mind sharp as we get older. The Mediterranean diet is perfect for celiac disease because you just swap the wheat, rice, or quinoa for anything else, and everything is already naturally gluten-free.
Well, we also want to focus our attention on common families of different ages, and because of that, different needs. So what we did was to learn more about those mentioned conditions, and then we surveyed 65 families. We also worked on a series of questions asked by the families.
Maybe we could see the questions of your survey. Oh yes, I can see them in the poster. What ideas did you come up with?
Actually, most of the families in our survey know a lot about the Mediterranean diet, but they don't follow it always 100%. They have great questions for an expert about making simple changes to it even better.
Could you tell us a bit more about those interesting questions?
The people we talked to want to know which food will help their brain to work better or give them more energy. They were also curious in minerals and vitamins and where to find it. Also, many people want to know full dinner ideas. I think this is a great area to focus on. Oh, definitely. Families sometimes need a hand figuring out what's balanced and healthy. But no, it's tempting to grab pastries or unhealthy snacks. But we have to fight that habit. They are grown for kids and they can be seriously addictive.
I understand that your proposal has something to do with this idea, doesn't it?
That's right. Our dinners are based on solid nutritional advice because prevention is key. The Mediterranean diet is great for staying healthy, and it's also easily adaptable to any specific dietary needs.
Our work isn't just about dinner, it's about school snacks too. Now parents sometimes are working out of the house at this day. Just isn't too much time to do good meals.
That's right. By eating junk food, our body releases a big burst of chemicals called dopamine, which make you want to eat more and more.
Great idea, but let's get back to the studies. During your researching, did you interview any experts?
Actually, our research lab at the university and chatted about some good topics. For example, between the difference of the olive and seed oil, the difference between the white and oily fish, sugar intake, benefits of fiber, and stuff like that.
That's right. We also talked about the differences between allergies and intolerances, and which is a big deal for a lot of families, and how this diet affects health.
Great, so you're a big fan of the Mediterranean diet, right? Did your conclusions support your hypothesis?
Yes, definitely. So we can say, eat healthy, stay healthy.
Thank you for the presentation. I was wondering, what was the part that surprised you more, or the result that surprised you more from the experiment?
Well, I think I cannot. We learned that the Mediterranean diet, well, at the families in our school, know a lot about it, but they don't always know fully how it goes and what.
So does your research has any impact on the environment or like?
Well, if you follow the Mediterranean diet, you can also stay healthy, and if you have like chronic diseases or problems, it's also easily adaptable, and well, it's great for staying healthy, and also it's very good for your body. And many scientists researched it a lot, so it's very good.
How did you collect the data of all the families and then analyze it?
We made a Google Forms, and at the end of the day, we checked all the information, and we printed it and put it in our course.
Okay. Okay, thank you very much.
We also have QR codes which you can stick in your fridge, and inside these QR codes you have diets and meals that you can follow, like snacks, healthy snacks to go to school, or dinners.
Right? The first.
Wait, there's not a fire yet. Those started with an observation. We observed, studied, and improved ourselves.
The city, the rivers, mountains are part of our environment. We have seen that forests are around us.
Oxygen are home to many animals and contribute to our well-being. That's why we must protect them. That's true. Your observation is good, but forests are also in danger. People don't take care of them, and climate change causes a lot of damage. And this is a really big problem.
Indeed, we realized that every summer there are more fires near us.
And we saw that they happen more when it is very hot.
And there is wind,
And when the environment is dry,
In other words, temperature, wind, and humidity.
when these variables come together, we call it the rule of 30.
so we asked ourselves a question.
Can we prevent forest fires using meteorological data?
That question is very important for us as firefighters.
Then we made a hypothesis that is a possible answer.
We thought that if we detect risk situations using the rule of 30,
And increase humidity,
then we can prevent fires before they even start. So our hypothesis was clear. We can prevent forest fires before they happen using the rules of 30.
That could mean getting ahead of the fire. That's a great idea. The rule of 30 is very important in forest fires.
It tells us when the fire is more likely to start. When the temperature is above 30 degrees, the wind above 30 kilometers per hour, and the humidity below 30%.
When these two conditions are met, the fire can start and spread very quickly.
That's why we decided to measure these three factors in our project.
then we move on to an experimentation.
We analyzed real forest fire data. Near us, do you know Mountain Cava? Well, a few years ago, it put people, animals, and plants at risk. We create graphs of what happened that day.
And we create a risk indicator using a particulate system. This way we translate forest language to data we can understand.
And using a formula, we combine the data to find the risk indicator. Green, low risk. Yellow, medium risk, and red, high risk.
And we discovered something very important.
When humidity increases, risk decreases.
So we built a prototype.
A weather station with sensors.
It measured temperature, humidity, and wind.
And when it detects danger,
It activates sprinklers.
We increase the humidity.
We think that the best way to prove it is by doing a demonstration.
Together, Desiree,
Mario,
Lucas, Paula, and all the class, we built this model of mountain fava using different materials and even a 3D printer.
and our prototype was made with a microboard and several sensors and engines that measures temperature, wind, and humidity, and activates a water spray.
for this demonstration, we will use a hair dryer because it can generate these conditions. So imagine the temperature rises.
The wind increases and the humidity drops.
The system detects risk
And activates water to prevent the fire. The system
So now measuring the conditions, the temperature, and weight.
Then we check if it works.
And if humidity increases, breeze decreases.
Our hypothesis was correct.
That's amazing. You must be the one. All scientists should know this.
Several experts helped us in this project.
We started with a firefighter who explained his job, and then we contacted some university biologists to show that our project applied us.
This is fantastic work and will help people, animals, and the environment. But forests may still be in danger. What can we do?
So our conclusion is clear.
Science and technology can help us to prevent fires.
But they are not enough now. We need to raise awareness among everyone.
We must all take care of forests.
Don't throw rubbish, recycle.
Plant trees and respect nature.
We learn to think like scientists.
To observe. To ask questions.
And to find solutions.
Protecting the forest is not an option. It's our responsibility.
Questions? How did you discover that humidity decreases fire risk?
We thought that if when a fire starts, the firefighters normally pour water and the fire stops, so we can do the same, but before it starts.
Did you program the microbes yourselves?
We programmed it by ourselves with help of our teachers.
How did you distribute the work? It's massive work that you've done.
We did it with help of our teachers, but we paint and we do a lot of things. And it's
It is indeed. Okay, thank you very much. Ah.
Sí. Okay.
Oh, wait. My name is Angel Kish, a scientist who studies how diet affects food.
And I'm Nancy Widowson. I research about nutrition and how it shapes our body.
But something feels different.
Let's observe how people eat today. Look, over there.
Hello, good morning. How did you sleep?
Very well. I'm hungry. I want to eat breakfast.
Everything is fruits, cereals, pastries, cookies, and a milkshake.
Great. That looks colorful, but it's peaceful.
Let's check.
The juice, 10 grams of sugar. About 2 sugar cubes.
Cereals, 17 grams of sugar. About 4 cubes.
The pastry, 27 grams of sugar. About 7 sugar cubes.
That's already more than recommended. Just for breakfast.
And we didn't even count the cookies and the milkshake.
This is not only this family. It's a global problem. According to the organization, adults should eat a maximum of 6 sugar cubes per day. But in some countries like USA, people reach 30 sugar cubes daily.
And too much sugar increases the risk of diseases like type 2 diabetes, obesity, and heart problems.
In fact, obesity has nearly tripled worldwide since 1975.
And children are the most affected. In some countries, they get up 25% of their energy from sugar.
The surprising part is that no sugar is hidden in everyday food.
Drinks, cereals, even food that looks healthy.
So the problem is not only sugar, but how much we eat without noticing.
So is this going to happen to me?
Maybe if it becomes a habit.
That's because your body is reacting to sugar.
And then, if it happens to overfeed, it can cause problems like diabetes.
And the extra sugar?
It is stored as fat and carry obesity.
Does it affect anything else?
Yes, your heart, your liver, and your teeth.
Diabetes?
Exactly.
I want to eat better.
And I will help you. I have an idea. Let's play again. Can you help me? For volunteers. The game is you have to guess how much sugar have these products. Thank you for playing. The correct answers are the ketchup is 55 grams of sugar. Wrong. The barbecue sauce has 90 grams of sugar. Correct. The tomato sauce has 26 grams of sugar. Correct. And the pizza has 47 grams of sugar. No. Let's go to school. Good morning.
Good morning. Today I have an idea. We will explore the world for breakfast.
How?
This year in Navarra, we are working in world connecting cultures and people. That's why I prepared better options to sugar. From Morocco, from Mexico, avocado, eggs, tomato, and tortillas.
Healthy and low in sugar and nutrition.
From Morocco, olive oil, cheese, fruit, and whole wheat bread.
Delicious and no added sugar.
We have even more recipes around the world. I want to try it. I want to take it.
Interesting. So tell us, what did you learn?
Food is more than nutrition, to make cultures and people.
And we must be careful with sugar, especially with the hidden ones.
Let's make healthy choices.
Eat smart, feel strong, connect the world.
So after this project, did you change your way of eating?
For this project, I have prepared pastries, and now I have to sell pastries. For this project, I have for breakfast cookies and I have toast.
After doing this project, I changed the orange juice that I normally buy in a supermarket from a natural one.
And before this project, I I have for breakfast cookies and music, but after that I have oil and
After changing your diet, have you noticed some difference in your energy or something like that?
And now I have more energy than before, and I run more and
I have more energy and I like to do more things and this.
Anything else? No? Okay. That's it then. Thank you very much. Okay.
Hello, my name is Lola. Hello, my name is Ariel. My name is Lola. My name is Maria. My name is Alora. We are dressed like this because we are protecting the beavers. We are going to talk about the beaver ripple effect. We have been chosen this title because the ripple effect means that one little change affects too many things. In real life, it means that one change affect too many changes, too many things. Question: we have been working with ecosystems and beavers. We heard about beavers in Navarra, so we wanted to investigate if they are good or bad for us. Hypothesis. At the beginning, we thought that the beavers are good and not a big problem for Navarra, and the only bad thing is that they eat.
Research. One day in science, we investigated about Yellowstone. A long time ago, humans killed wolves, and this changed everything. With no wolves, in Yellowstone, the animals like deer and coyotes population grew, and trees were eaten by
by deers and changing rivers. Do you want to know how? This is an ecosystem without trees. When it rains, the water goes with soil because it not has trees. And this is another ecosystem with trees. But now the roots take the soil and only the water goes with only water.
Characteristics of the beaver. The beaver are rodents. They have a special tail, strong teeth, and adult legs. They have a thick fur that reproduce an oily substance called castor. Here you have the picture about his characteristics. Uh, uh, beavers came. Beavers came to. No, beavers go very years ago. In 2003, beavers returned after an illegal reintroduction in the Aragon River, Funes. Here you have evolution from 2003 to today, in representing with these maps. What beavers eat? The trees that beaver almost eat are poplar, chopos, and willow sauces. Here in the graph you can see types of trees that beavers already eat. They also eat white poplar, elms, and ash.
Are they good or bad? Newspapers usually talk that white problems caused by beavers, but we wanted to learn by scientists. One day we had a visit from Gaby Berasategui from Ornitholand. We learned something different. They help ecosystems become healthier, and many other things about them.
We can live and protect together. First, we put wireless to protect trees, but in Navarra we don't use this a lot. We also use a mix that Gabi shows into oil and sand, that the beaver don't like the oil, and the sand he put in his teeth and they don't like. Monitoring. A monitoring is a camera so we can see beavers at night because they are more interactive. Third, safety action. We only cut the tree if the beaver eats but don't finish eating, and it's dangerous because can fall down and people can die. Analysis. The beavers do benefits and problems to the world. A lot of benefits are that they create wetlands which are nice for many animals. They create their dams slow down water that they do that are not a lot of problems to the village. They clean the water because they have many capsules in their tanks. The beavers are called ecosystem engineers because they help in very lot of ways the ecosystem. In an experiment, we do that if in a village don't have a dam, the village can have a lot of problems. But if in a village we have dams, the village don't have problems. Now the negative. The beavers cut down a lot of trees which can damage forests near rivers. Their dams flood farmland or floods. They can change river flow and So people sometimes need to protect their trees because if not, people that live near the river can die. Conclusion. Beavers in Navarra have good things and bad, but we have to think in the good things because if not, a lot of people want to kill the beavers. Beavers will matter. Let's build it together. And this is our project. I hope you like it.
So, did you see by yourselves any positive or negative aspect of the beavers surrounding us?
Yes and no, because sometimes we think about people see in newspaper, but others we think that they can do it by
Why did you decide on this topic?
One day we were working with ecosystems and we looked that in Navarra they came beavers. And so because he came to Pamplona, we do it of the beavers.
Okay. When you were with Ornitolab, did you manage to do the safety actions in the trees? Any of them? No? Like if you try to put the oil with on the trees or anything like that?
Because Gabi don't shower mix, but we don't put in the trees because in the school we don't have trees.
Obvious. Maybe you plan a trip to the river to see it. Next time. You can ask the teacher for next year.
More questions?
Okay, thank you very much. Very well done. Cheers.
Good morning, everyone, and thank you all for being here. I am Amir, and I am representing Ines Basoko along with my teammates, Malak, Chaima, and Martina. We are here to talk about pH and how it changes in our mouth when we eat sugary food. First, we want to present our main question. How does pH change when we eat food mainly composed of sugar, and how effective is toothpaste reducing this acidity? Before explaining our experiment, it is important to know what pH is and why it matters. pH is a scale that tells us if something is acidic or basic. This scale goes from 0 to 14. If something has a pH of 7, it is neutral. If it is higher than 7, it is basic. And if it is lower, it is acidic. Sorry. This is something that we can see in our everyday life. For example, some drinks like soda and juice are acidic, while other things like soap are more basic. Now, focusing on our mouth, the normal pH is usually close to neutral, which is good for our teeth. However, when we eat sugar, something important happens. The bacteria in our mouth use sugar and produce acids. Because of this, the pH goes down and our mouth becomes more acid. This is a problem because acids can damage our teeth little by little. Over time, they can cause cavities and other dental problems. Also, many people eat sweets every day, so this is something that can affect everyone. This is why we decided to study pH and how it changes in our mouth when we eat sugar elements and how we can reduce this acidity.
Hello, my name is Malak and I will be explaining the following information. After knowing and understanding what the pH is, we decided to formulate our hypothesis. We thought that the pH would go down because of the acids produced in our mouths. To test this idea, we decided to make an experiment. The materials that were used were pH strips, toothpaste, toothbrush, lollipops, or licorice, a red cabbage, and a chronometer. Firstly, we measured the pH of our mouths. We measured the pH of our mouths before eating anything. We measured it with pH strips, which are really simple to use. They change color depending on the pH in our mouths. The first step helps us know our natural pH, and then we're gonna eat some sweets, such as lollipops or cakes. After these, after that, we measure the pH to see if it increased. We expected the pH to go lower because of the acids. Then we wanted to see if we could change our pH back to normal. So we used toothpaste. We brushed our teeth for an specific period of time. Then we measured again our pH with the pH strips, and to make the experiment more visual, we're going to use red cabbage. Red cabbage is useful because it changes the pH depending. It changes colors depending on the pH. Sorry. And this helps us to see the change colors in a more clear and interesting way.
Hello everyone, I'm China and I'm going to be talking about the results of our experiment. First of all, after we ate sweets such as lollipops, we measured our pH level and we saw that it decreased, which means that the pH level was acid. This was an important point for our presentation because it confirmed our hypothesis. Then we tried to see if the toothpaste increased or decreased the pH level of the saliva. We saw after that the pH level increased after we brushed our teeth. Here there is a graphic, and you can see that I'm the black one, and I the most acid one. And in the green, there's a beer, and it's the most basic one. You can either increase your pH level with pH regulator candles or toothbrush. Here we're seeing that a beer is extracting the natural indicator of pH, and now she's going to mix it with bicarbonate and vinegar. You can see over here. So after that, if the pH level shows red or pink, it means it's acid. And if you see a blue or a purple color, it means that it's basic or more neutral pH. Here you can see. You look, this is a very basic level. Here you can see. We calculate this is a pH 7 or a pH 8. You see it here. And in the other one, it's turning kind of pink. This means it's either a pH 4 or a pH 5. This helps us to know that there are more ways to find out the pH level by other natural techniques.
Hello, my name is Martina and I'm in charge of finishing up our presentation. Let's start talking about the problems, the difficulties that we found during our project and concluding everything. Okay, so for starters, we could clearly see that sugar makes our mouth more acid because the intake of this substance acidifies our mouth really quickly and makes a risky environment for our teeth. However, when we regulating agents such as pH regulating candy or toothpaste help alkalize the saliva and neutralize the acid and the acid pH, bringing back the balance to the oral environment. We could also see that our pH variated not only on the foods that we ate, but also on the person. For example, if I eat a lollipop, my pH could be acider than China's. For this reason, we think that this may have a genetic explanation. However, taking the acid pH and the acid pH and completely neutralizing it so that our mouths can be basic at almost all times. During this project, we also have in the first day we did with the red cabbage, we took the first leaves of the red cabbage and they were dry. So the color, it wasn't like a strong color, and it was difficult to clearly state the differences between one pH and another. Also, it was difficult to state which food caused a major pH change in our mouths, because every time we did it, it could give different results. Even with these difficulties, we are grateful that we got the chance to be here and that we chose our pH as our project, because this helps us understand the importance of brushing our teeth daily and having a balanced oral environment. That's all.
Taking into account the data you have in your graph, with the same habits, doing the same things, which person is the one with more probabilities of having cavities in the tooth?
In this case, I have, if you can see, I have the most acid pH, which means I have more probabilities to have cavities. Because acidity breaks, kind of damages our teeth. So that's why.
Do you know which is the process in which the bacteria just use the sugars to produce acid?
So, as we said, the bacteria in our mouth, when we eat sugar, they break the bonds and create acids, which we said that could be harmful for our teeth. So, I don't actually know how to explain it, but our mouth, the saliva of our mouth, takes that sugar and kind of inserts it in our tongue and those things. But after brushing your teeth, for example, or eating a red candy, your pH could go up again.
Another question. So if you have an acid pH, you have risks to have cavities, but it is safe to have a basic pH?
Yes, absolutely. And it is more safe. And it's more like improbable that you have cavities, and that's why it's safe. So you have a safe mouth. Any more questions?
Okay. One more. No, it's okay.
Then last one. You said that you try different food before testing the pH. Can you explain a little bit further which food did you try and the difference you saw with this choice?
We tried lots of food, like our own lunch, such as sandwiches, tangerines, oranges, sweets, and we saw that, for example, sweets have more sugar, so they acidify your pH more, and sandwich, for example, doesn't really like change anything because, like, for example, a cheese sandwich doesn't change the pH almost at all. It only changes like one, if you're lucky, like one. Yes, but and the candies and the tangerine just lowers your pH and makes it like much more acidic. That's why we chose candies for the experiment. Thank you.
Thank you.
There she is. Go ahead.
Hello. Okay. Hello, everybody. We are a group of the School of Escolares Random of Pamplona. First of all, our names are and we are represent you our project called Let's Bacon Little Bread Really Good. First of all, I am going to explain you the main products that we have used for done this project. That are vapor disposable with nicotine, and some recage, and another vape, but in this case it's a pod without nicotine. And also we have used a vacuum pump, a gas trap, and other products that also we have used are cotton, a lighter, stopwatch, food, and more things. Okay, and now our hypothesis about this project. We thought that in vape without nicotine don't less a lot of waste products than one that has nicotine, because the nicotine is the most dangerous products that has a vape. And with the second hypothesis that we have articulated is that the vape with nicotine less more waste products than one that don't have.
Experiment experiment consists of showing how much residues of tobacco, vape with nicotine and vape without nicotine lives in our lungs when we smoke or vape. Smoking and vaping isn't allowed for people under 18 years old. So we did our experiment in a smoke extraction room. Our experiment was the gas drum. In the entrail, we place a little cotton, seeming an artificial lung, and then we put the vape or a cigarette. When the cigarette and the vape finish vaping or smoking, we take off the little cotton, and then we can see that it's more yellow or brown. These are the tables of the cigarettes, the vape with nicotine and the vape without nicotine.
Yeah, if we see the results of our experiments, we will see that the tobacco absorbs less products than the vape or our experiments. So we will say that our artificial lung didn't absorb all the substance that passed through it, and we could say that because of the color of the water that we use for the experiment, because it turns yellow and the smell that it produces. Also, we do slay to the families of our school. The results are so interesting, and almost 4,000 people have responded. Many of them were women, and the 48%, 78% of the people say that didn't smoke actually or take vape, and the 92% of the people say that didn't have any familiar or friend that smoke actually. So we also see that the medium age for start vaping is between 14 and 20 years old, and the people that smoke vape do it usually with nicotine. We could say also that the family says that the 80% of the people are agree of say that smoke or take vape is dangerous for your health.
How it works, a vape? A vape or electronic cigarette works like it's a battery powered that heats a liquid with nicotine and other chemicals. This liquid creates an aerosol, and that aerosol is what you inhale. We have to remember it's dangerous, specifically for young people. Our conclusions. On conclusion, the tobacco produces more solid residues and the vape more liquid residues. The people that smoke normally smoke tobacco, but on young people it's normally to smoke vape. And the women are more concerned about this topic.
Okay, for end this presentation and our project, I want to say three things that they are very important. Number three, this project isn't done without three persons that have helped us all this session that we are doing this. Alcohol, Ethan, Lua, and Unai. The second thing, I want to make you a question. Don't think that the vape makes you cooler, stronger, and freer. All the time I repeat, take something from you. In some cases, it could be your own life. And I want to now I respond. It's worth it. It's a priority. Get all the day consume a lot of vape and cigarettes that can kill us. But this is something that I can control. It's your opinion and it's your decision. And now, thank you. But if you have a question and all of this, you can ask me, ask all my group. And also we can do a demonstration that the vape or the tobacco in this case could danger your lungs. Thank you. And your.
So why did you choose this project?
I think. Yeah. Who wants to answer?
We think that it's so actually because all the teenagers now vape or smoke, and also we think it's so interesting because we thought it's a really bad thing, but other people thought it's like so good, and that's here we are showing that it's not really good.
Do you think that this project will make you stop from vaping?
First of all, no one of us vapes, but I think it cannot stop vaping, but can conscience the people that vape.
You saw different results from waste. Some were solid and others were liquid. And did you see any difference in the gases? The gases.
We saw that here, when we use the vape, there was little drops, but with the tobacco, it wasn't.
Maybe I missed it, but how did you make the measurements of quantification of the waste?
We can.
I can repeat the question, please. I don't understand, sorry.
Yes, I wanted to know how did you measure the differences between the waste in the cotton to say which one has more? Yes? No?
We can make a demonstration of that question, but it needs fire, and I don't think here is.
So that was
I mean,
Do you want to see the experiment?
Yeah, we have.
Yeah, I have seen there some balance or have you measured the have you used it?
Okay. When you take the cotton and you put it on the gas trap, and in this same time, and all the waste products and a lot of these products, they stay here. And first we put the cotton, what was. It was about 70 milligrams, and when we put it again, we put here, the weight was more than was. In some moments was a lot of, because it's very, if you can see here, here we weight the cotton, and here we put the absorption that they make it for the weight perspective. It is your
yes, that was my question. I wanted you to explain me what was the meaning of those data.
We have, it's only for seeing, it was more yellow or here.
But,
okay, sorry.
Okay then?
Yes.
Yes? Thank you very much. go ahead.
We come from Navarra, Yeast. Today we're going to talk about how yeast reacts with sugar.
Okay, so the materials we will need for this project, only 6 materials. A thermo with hot water, a bottle, recycled better, a balloon, yeast, sugar, and a thermometer.
First of all, I will start explaining a little bit about background investigation so later on you can really understand what we actually did with this project. First, I'll start explaining what is yeast if some of you don't know it. Yeast is a living unicellular microscopic fungus. Some people think it's a chemical substance, but it isn't. Some of its characteristics that it fits in sugar, especially in this experiment. You will see that later on. It produces energy that can also be transformed into CO2 and alcohol, for example, in wines. But in this project, we'll be working with CO2. It also produces much more things that we're just gonna talk about that. And its process of surviving is fermentation, and I'll explain that right now. Fermentation is an anaerobic process, which means it doesn't need much oxygen, so it's its way of surviving. And in this process, it may produce, as I already said, CO2 or alcohol, and this is a way you can produce or you can make wines, breads, and that type of things. What happens when we actually mix water, sugar, and yeast? What actually happens is that since yeast is a live organism, it's living, when you put it in water and you mix that with sugar, it starts feeding on it, and after feeding on it, it starts producing all that gases, and that gases go up. So you'll see why this is relevant further on. For example, this is how yeast looks in a microscope, and I'll let more explaining to Aina.
Okay, so why is the temperature important? On cold temperatures, the yeast works slowly, so we can use cold. On warm temperatures, the yeast works better. But on very hot temperatures, the yeast dies, so we can use. This is why the temperature is.
Now I'm going to talk how did we do the experiment. First, we heat the water in a kettle until it gets 20 degrees, and then we pour the water and the sugar with the help of the panel. And then after that, we put the yeast, and very faster, we put the balloon over the mouth of the balloon. And finally, we shake it with a careful movement, and then we repeat the process with the next temperature, 30, 40, 50, and 60.
So we tried this experiment with 5 different bottles with different temperatures, and at 20 degrees the balloon got bigger, but slowly, very slowly, and at 30 and 40 degrees it got the most big the balloon could, and finally, and at 50 and 60 degrees, the yeast died, so the balloon got smaller. So yeah.
I also explained this because I think it's quite important. And these gases that you might think they're almost invisible are actually sometimes visible. For example, when you are cooking some bread or when you are eating croissants, you were just eating it, so you can notice it. When you eat croissants, you see there's like small spaces, or when you eat bread, there is space in between that bread. That's because the yeast actually starts activating and all the gases go up, but they can't get out because that's just a whole mixture, so you can't get that out.
So I forgot to tell you all that this is what the results were like, and this is before the 20 minutes of waiting, and this is with the waiting 20 minutes after. So we can see that with 20 degrees,
it got bigger, but very slowly and not too big.
Well, our main hypothesis was that the hotter the water was, the more the balloon would inflate. But this hypothesis was incorrect because the yeast only works between 30 and 40 grades. Well, this is our experiment, and I hope you like it as much as we do. Thank you. This is not math, it's science.
Like you know, already mentioned, this is not magic, this is science. So if you've got any questions we can resolve for you, you can really ask them. So is there questions?
So you are measuring some gases. Which one is the one you're measuring in the balloon?
What?
Which one is the gas you're measuring in the balloon? Do you know that?
We are actually measuring CO2 because there isn't any fruit that actually puts out alcohol. Like for example, in breads, you also measure the CO2 because that's what is going out of it, because there's nothing chemical that produces alcohol if there is enough fruit in there.
So for each experiment, you waited for 20 minutes, right?
Yes.
Do you think the temperature of the mixture keeps constant during those 20 minutes?
So we actually didn't wait for 20 minutes in each bottle because, as I said earlier, with 20 degrees it got bigger but slower. So with 30 degrees and 40 degrees, it got faster. But as you asked, no, the temperature didn't actually change much.
So you waited different times for each different temperature to get to know how much gases you got? Okay.
We actually, some of us, I don't know if she did that, but for example, Sienna, we all waited a couple of minutes, like we tried to wait around 20 and 25 minutes to actually see if it would get constant, but obviously the more you let it there, the more it will inflate because that's just how it works. That's why also when you're doing some type of recipe, you need to let it like 2, 3 to 4 hours, so it lets it grow, and the after result is like much softer and crunchier on the outside. Anything else?
Yeah. Did you try any different sugar to see if it was faster?
No. We just use sugar.
Okay. This is it.
Thank you.
Okay, go ahead.
Good morning. We are Nicolás, Ángel, Máximo, and Akane from the school Yeast in Australia. And today we are going to present you this experiment, the effect of fertilizers.
We have worked on this project because we think that water contamination is a very serious problem on the earth, and fertilizers are a big part of it. Our motivation is that fertilizers made from organic waste can be better than chemical fertilizers that help, but they are pollutant. We thought that we have to prove that we can replace chemical fertilizers with organic fertilizers. So we searched on the internet to find out which type of waste products have more beneficial benefits.
Our findings were that banana peel has the traditional combination of calcium and phosphorus, eggs has a lot of calcium and some nutrients
Type and Pico as triple, and Ash has phosphorus and calcium. With these results, we thought that it's possible to make organic fertilizers that work well on plants, and this is our experiment. The title of our project is Effective Fertilizers, and the question we have tried to answer is how does a plant grow with different fertilizers?
Hypothesis. On one side, we thought that the chemical fertilizer that we buy at the shop would work very well, but it is well as a pollutant. On the other side, we thought that the handmade fertilizer that will work well than the chemical fertilizer or better, and it isn't was a pollutant.
The materials we used were 4 big plants, chemical fertilizer, handmade fertilizer made from banana peels and eggshells, a handmade fertilizer made from paper and ash, water, a conductivity sensor, and a computer.
The procedure was the following. First, we planted 4 plants in 4 different pots. And then we measured the initial height of the plants. Like this. Then we prepared the different fertilizers. First, we bought the chemical fertilizer which was added to plant number 1. Then we made banana tea and eggshell powder to make the handmade fertilizer which was added to plant number 2. And we triturated paper with ash to make the fertilizer which was added to plant number 3. The plant number 4 was watered only with water.
And the plant feed, we measure them and reports of the plants every day. Also, we measure of the conductivity of the soil with an electrical conductivity sensor. Also, we made some tables and graphs with the results. And finally, we made the mural representation to show you this experiment.
We are going to show you the growing of the plants. We have made some time lapse. This is the plant number 1, the fertilizer. And this is the growing. This is not until now because we can't measure all the time. This is plant number 2. Number 3. Don't work.
This is plant number 4.
And these are the measures.
After some weeks, we noticed that when we applied the fertilizer to all the plants except one that it was used water, they grow more. The increasing height between the first day and the last day was 14.5 centimeters in the plant treated with chemical fertilizer, 15 centimeters in the plant treated with handmade fertilizer made with banana peels and eggshell, and 14 centimeters in the plant treated with paper and ash fertilizer. The plant water with water increased 12 centimeters.
Using a conductivity sensor, we measure soil conductivity to see which plant had the most minerals or nutrients. The result was that the handmade fertilizer, made from banana peel and eggshell, which provide phosphorus and calcium respectively, had the most minerals or nutrients, followed by the chemical fertilizer and then by the paper and ash fertilizer, which didn't have a large. We believe that the nutrients came only from the ash, not the paper, or that the paper contributed very little, because the paper was very cheap. Finally, the plant with just water didn't have as many minerals as the others.
Our conclusions were the homemade fertilizer made from an apple and eggshell was the best and the most productive. The artificial fertilizers was also productive, but it's productive unlike the homemade fertilizer made for organic waste. This suggests that the chemical fertilizers could be replaced by organic alternative that is less productive. Also, it would help reduce the amount of organic waste produced. And that's all.
Thank you very much.
How did you prepare the banana peel and Excel fertilizer?
We searched on the internet the recipe, but in this one figure it's only 3 But in this one, in the harmony fertilizer with banana peel and Excel powder, the Excel we decorated a lot, and it's a powder. And the tea, the banana peel,
Boil.
Boil and it's got a tea, and then we apply to the
Do you think there could be any other influence on the growth of the plants apart from just using different fertilizers like the sun, the water, where they were? I don't know.
They were very near the H1, so we don't know if there is another factor.
These are the four plants you have used. Yes. You have done it once. You have done it once.
You can repeat the question?
No. I wanted to know if you have done it once or you have done more repetitions of the experiment.
No, we don't do any repetition, but first we plant the seeds in the soil, but it don't germinate for and we and with that problem we plant the pea plant these plants because they don't germinate.
Why do you choose pea plants and not a different type?
Because pea plants affect, they have a lot of nitrogen, and so they absorb the nutrients very well, and so they affect, the fertilizers affect more the plants. So to make it more visual.
If you chose a different plant, do you think the results would be the same?
Depend on the plant.
The plants, I think that we think that the results will be similar, but with different measures.
Okay. Thank you.
Good morning to everyone. Good morning to everyone. We are from the school in ISTD. My name is Lucia. I'm a geologist and a research center on the greenhouse. Today we are going to talk about how carbon dioxide affects oceans, otherwise called ocean acidification. We all have heard about the greenhouse effect that is slowly rising the temperature of the atmosphere. But what happens to oceans when CO2 levels rise? To better understand the topic of ocean acidification, I first need to explain the greenhouse
Carbon dioxide, or CO2, is a major gas that it causes the Earth's temperature to rise, a process known as the greenhouse effect. Deforestation, burning fossils and fuels, use of fertilizers in agriculture, livestock handling, and the composition of organic materials in landfills are some reasons why levels of carbon dioxide are rising. Thanks to recent investigations, we know that carbon dioxide has risen from 1.1 ppm to 3 ppm in the last 10 years, as you can see in that. ppm stands for parts of gas per million parts of air. We wonder if an increase of CO2 levels in the atmosphere may have an impact.
Hello, I'm Fernando, and well, I'm the chemist. And yes, in fact, as you've seen in the graphs, there has been an increase of CO2 in the atmosphere for the last years. We all know this has caused temperatures to rise, but what nobody seems to notice is what happens in the ocean. To prove our theory that CO2 could affect the oceans, we conducted an experiment in which we mixed red cabbage juice, a known pH indicator, with water. My colleagues, Natalia and Lucia, are going to perform this experiment now. As you can see, after a little bit of going into the water changed color, indicating a decrease in the pH of water.
Thanks, Fernando. Hi, my name is Gonzaga and I'm the ecologist, and my research is focused on the impact of CO2. As Fernando has said, when CO2 is mixed with water, it lowers the pH. Actually, our oceans absorb about 30% of CO2 emissions. When water dissolves in carbon dioxide, it triggers a chemical reaction that releases carbonic acid and hydrogen ions, leading to a process known as ocean acidification and causing a decrease in pH.
Whoa, that's almost magic. Do you think this may have an impact on marine life?
Oh, that's a great question, Lucia. Hello, my name is Natalie. I'm the oceanographer, and my role in this project is to investigate how carbon dioxide emissions affect marine animals. And of course it does. In fact, we carried out this experiment that proves carbon dioxide emissions affect marine organisms. We use different concentrations of vinegar, which contains acetic acid, and water. We use 4 different containers with 4 different concentrations, from 100% vinegar that has a 2.26 pH to 100% water that has a 6.19. We measure the weight of the shells daily, and thanks to this, we found out that they dissolve quicker in lower amounts of pH. As you can see, this graph shows how pH has been decreasing over the last few years. And these 2 other graphs are our own results with the graph we made ourselves. The experimental results show a progressive daily loss in some mass, with some eventually disappearing. In addition, the graphs reveal an increase in pH over time, suggesting increasingly acidic conditions that likely contributed to cell dissolution and structural weakening.
This process is very interesting from a scientific point of view. The acetic acid reacts with the calcium carbonate, forming calcium acetate and carbonic acid, which is very unstable, and it quickly breaks down into water and CO2, and as a result, you can see the bubbles. You can see bubbles, and the water is linked like so.
This process directly impacts marine organisms with calcium carbonate shells and skeletons. As ocean acidity increases, their ability to form and maintain these structures is reduced, making them more fragile and vulnerable to dissolution. As my colleague Lucia said before, greenhouse effect is not bad, but big amounts of CO2 damage Earth. In the left side is illustrated a balanced system with moderate CO2 levels and healthy marine life, whereas the right side shows the consequences of anthropogenic CO2 emissions, leading to a process known as ocean acidification, increased hydrogen ion concentrations, and harm to marine organisms with calcium carbonate. Our results demonstrate a direct link between atmospheric pollution and ocean ecosystems. As CO2 emissions increase due to human activities such as burning fossil fuels, the chemistry of the ocean changes. This chemical imbalance can negatively affect marine organisms like corals, mollusks, and plankton. As a conclusion, and plankton, potentially disrupting marine food webs and biodiversity. In conclusion, ocean acidification is a clear example of how human-induced changes in the atmosphere can alter ocean chemistry and threaten marine life. In addition, and disrupting marine life. Addressing CO2 emissions is therefore essential not only to mitigate global warming, but also to protect and stabilize ocean ecosystems.
Thank you very much. That's the end. If you have any questions, we're very happy to answer your questions.
What was the most difficult part in the project?
While we have been doing the change of pH, sometimes the results were not good because we put big amounts of red cabbage juice, and when we put only a little bit, like 5 milliliters, you can see that it changes pH.
Well, I have a tricky question maybe. Did you use salt water? And if don't, do you think it has an impact on the expert? I said it was tricky.
Thank you very much. Second question. We have not tried experimenting with salt water. We are going to investigate.
Thank you.
Maybe you said it, but I didn't get it. Do you have an idea on the change of pH of the oceans during these years? Like you said, the ppms changed, but what about the pH of the oceans?
The pH in the oceans has been decreasing. As I said, the graph results show how the pH has been decreasing in the surface seawater level.
Okay, this is it then. Thank you.